Oh, I'm Bill Wong with Electronic Design, and we're here to talk to Texas Instruments about battery management systems. So you tell us what we're going to be seeing.
Yes, so we're actually featuring our high voltage battery management system here today at CES. So we are actually working with a company called Comemso to provide us with a hardware and loop simulator. And what this is, basically we can get cell voltages provided to us, the temperatures, the isolation resistance, and another, current, like a current value given to us. So what we have to do with that is we use that as an input to our system. So we're going to come over here and take a look at the connections to our board. So that Hill simulator is providing all those cell voltages, the temperature readings, the shunt currents, right? We're actually monitoring a shunt here, and those are all being monitored by our cell monitors, connected to our pack monitors, and going to various other areas. And if you look at this here, we have an entire BMS development. It's actually an entire battery management system. Mm-hmm. And by that, I mean it really is a BMS, okay? We're not actually just supplying a certain portion of it. If you look at this from a high level, let's just look at the number of black parts that you see on there, right? Those are silicon devices. Every single one of those black parts comes from TI.
Amazing.
There is no vendor that is in the entire industry that is able to claim that, to be able to develop the safety microcontroller, the battery monitors, the pack monitors, the isolated load switches, contactor drivers, Pyro Fuse drivers, the communication bridges, CAN transceivers, the buck converters. We have the whole gamut of devices.
Everything except the circuit board.
Everything except the circuit board. So if you look at the BMS system today, this is a BMS, but I'm really only showing a low voltage system.
Okay.
So low voltage system, why is that? Because 800 volt vehicles, it represents, it's high voltage and it's quite dangerous. So I really can only show 36 cell voltages coming into this system here. In an 800 volt vehicle, I'm going to have 200 cells. And this board, what I want you to think about is just envision how big an 800 volt board would be. And then at that point, think about how many black dots you're going to see on that board. And that tells you how big of a player, or how big BMS really is.
Amazing.
Right? So, you can even easily see there's going to be over 100 chips on these electrical vehicles for battery management.
Excellent.
So, I want to maybe show you here the overall structure of the board. And if you think about a battery management system, what do we have? We have three primary subsystems in let's say, a modernized BMS. Right. We've got the battery control unit, which is really the brain of the system. We've got the cell supervisor unit, which is actually connected to each and every one of those modules inside the battery pack. And then we've got the battery junction box, which we're starting to put so-called pack monitors inside these battery junction box, making them intelligent. And we're measuring currents, we're taking voltages, we are measuring isolation resistance values in them. So those are the three main subsystems. We got the battery management unit, the cell supervisor unit, and the battery junction box. So if we look at this board here, what we've got is the battery management unit. The red board here, it has the MCU. It's basically controlling the two cell supervisor units, and it is then interfacing to this battery junction box device, this pack monitor. And what we can do now, let's do something really fun. We can kind of imagine that you're gonna get into my car.
Excellent. So let's go take a look at it.
Yep. We're talking about the metaverse a lot. Let's imagine that we're getting in a meta vehicle, if you will. So hop in the car, and I'll be the driver. Okay.
Perfect.
So you trust my driving?
Yeah, we'll see.
I don't crash. Okay. So what we're gonna do is, I've got an on button here, okay? I'm just gonna hit the ignition. I'm sorry, there's no ignition. It's actually just a button, which is represented here, right? So I'm gonna start discharging. And, I'm American. I like Fast and Furious. I don't know how you drive, but I told you I drive safely, but I like Fast and Furious, right? Okay. But the Europeans, like my team is, in China and Europe, but they decided to go after an emission standard called the WLTP, the Worldwide Harmonized Light transition vehicle, right? So, so there is a discharge, or there's an emission standard called WLTP, which is classified in terms of a low profile, a middle profile, high, and extremely high. Well, I like extreme high discharge, and so what this will do once I hit the on button, it will basically simulate us going on a road. We'll be going uphill, downhill. It'll show the the voltages on the top in the graph in real time, and then it will show the current discharge profile. So either we're discharging in the negative direction or charging in the positive direction.
Sounds good.
Right? So strap in your seatbelts and let's go press this button, right?
All right.
So your eyes should be focused in this area here where we're taking a look at the wired CSUs. Now, our claim to fame is 1 millivolt accuracy, targeting to, and we can talk about this later, is basically targeting LFP type of battery cells. So we can see this is basically for all of the cell voltages. This is the BCS, which is here, the hill.
Right.
These are the hill voltages. The set points are going through this profile. Sorry, it's going through this profile here. And again, that's the WLTP standard, and this is your current profile. So these voltages are shifting and is provided directly by the hill. And now the measured cell voltage is from our device is this. So the comparison of that, what is your accuracy? So we're basically saying, we're putting our money where our mouth is and saying that the maximum inaccuracy that we've ever seen in this system is 1. So we're basically selling you exactly what we can have. Okay, so let's start turning up the music and let's start. What do you like listening to?
Rock and roll.
All right, let's turn it up. So, right? So let's just imagine that all of a sudden I get a fault in my system. I get an undervoltage fault, and you can see the hill basically sets the cell voltage to 2 volts. Now, you don't want to discharge lithium ion cells too much, and so their system is protecting, right? And it's saying you're in a fault situation, and your contactors, remember the contactors that we saw on the board?
Yes.
Those are now basically shut off. You're cut off because you're in that mode. So our system has detected the undervoltage, reported it to the MCU, and we have our contactor driver, which is shutting off the overall system. But though we're listening to music, we're having a good time, we don't really worry about that. So let's just clear the fault and let's just turn the car on again and just keep driving. Don't worry.
Off and running.
Don't worry. Because we don't really care about undervoltage. But maybe we drive 10 miles more and we get maybe over temperature fault. We get an over temperature fault injected here, right? And all of a sudden we get a fault indication. It's over temperature, and the contactors have just turned off. Well, again, we don't care, Bill. I don't really care if the cells overheat. I'm just going to keep driving to Dallas, right? So let's just clear the fault and keep driving. Well, all of a sudden we get an overcurrent, right? And the pack monitor is the one that's going to measure the current, right? So the overcurrent gets triggered. And this time you notice that I have a fault, contactors have opened, but you can't rely on a contactor when you say, let's say you have a 5,000 amp, which is what this is, a 5,000 amp scenario where something is completely wrong, right? So there are, pyro elements out there, kind of like melting fuses, but you trigger them, there are pyro devices that are getting, quite fashionable these days. And this device fires immediately, disconnecting the system from the load because you're under that high stress situation. So that kind of ends our journey because once that pyro fires its one-time element, and we're kind of stuck in the middle of the road here. But you can see what we're doing is we are actually able to stimulate the entire system with a smaller number of cells, but shows you how complete the overall portfolio is from Texas Instruments. Now, I do have more to show you. This was I didn't mention that in this system here, it was only a wired BMS. There is something called wireless BMS. So what we're showing here is a wireless BMS system. Now we're here at CES, and I don't have the luxury of showing a real vehicle, and I'm limited to my show floor. But BMS is really about monitoring a battery pack, right? You've got a battery pack on the underside of the vehicle, but BMS is about monitoring a battery pack. So what we're going to do is basically have a battery pack, which is connected to the load, in this case the inverter. But this battery pack is also connected to the cell supervisor unit, which we see on the back side here. So this features our battery monitor. We're actually showing the voltage, the current, as well as the reception strength, and we are transmitting that wirelessly over to the main node. If we look here on the top section where it says RC car, right, as I'm basically wirelessly transmitting the cell voltage value, the temperature, as well as the RSSI value. So what I see on the car is exactly shown here. And the cool thing is I'm actually able to drive this car on the show floor. So as I drive it, I'll be able to see the signal strength vary, The cell voltage vary potentially, but I don't really have a big space, so it's not going to vary that much. But I just wanted to show a wireless network, wireless BMS system, and put it into perspective as to what it means.
Well, thanks very much for showing us Texas Instruments battery management technology.
You're welcome.